Hello, everyone. Welcome to Int8, a webinar series by Segmind. Today, we have with us Dhruv Singal, who's a generative AI lead at NVIDIA. He's been at NVIDIA for over 3 years now, getting a ringside view of the generative space evolve. He's an expert in CUDA and has worked with the NVIDIA High Performance Computing team, Robotics team, and Deepstream team within NVIDIA. He then went on to establish the Inception Solutions engineering team to help startups leverage NVIDIA technologies. He's now building Picasso, NVIDIA's generative AI API offering. Welcome to the webinar, Dhruv. Excited to have you here.
Likewise, thanks for having me here.
Awesome. So I just wanted to start this off with learning more about your NVIDIA journey. How did you get into NVIDIA? What got you interested into joining NVIDIA?
Sure. I joined NVIDIA right out of university about 3 years ago. During my time in college, I'd interned there twice. Once as a Jetson intern, the second time on the Deepstream team. Um, After I finished my second internship, I accepted a return offer as a solutions architect, which was ambiguous at the time. And it just so happened that Inception was looking for some technical staff when I joined. So I joined them and established the solution engineering team for that. Yeah.
Awesome. So you worked at a couple of teams, including like Jetson and Deepstream. How was that? And if you could just help us understand what Jetson, and Deepstream are.
Sure. Uh, One of the reasons why I joined the solutions engineering team or created one was because I wanted to be extremely cross-functional and work with the entire software and hardware stack across the company. So I get to deal with Jetson and Deepstream in my day-to-day work as well. The Jetson is a single board computer from NVIDIA, which started off as their uh, it started off based on their work on their Tegra chip, which was built for the Nintendo Switch and NVIDIA's line of consoles slash or set-top boxes for gaming. Um, that SoC then went on to be put on a developer board for robotics, and it took off enough that they started launching more and more powerful developer boards. The Tegra SoC can be thought of as a ARM CPU, significantly more powerful than what you would see in a Raspberry Pi,
Got it.
attached to an NVIDIA GPU with NVIDIA IP on it.
Got it.
So that's the Jetson.
Right.
We After that, so on the Jetson team, what I was doing was I was building a chatbot for the robotics chip, so as to create assistants. For example, you'd go into an office and you'd have someone to answer questions for you. That's where this board would come into play and would be sitting in some kind of humanoid robot of some sort. Jetson is now used in all of the robots you see in warehouses and in grocery stores. If you have robots that move around or detect spills or do I'm forgetting the word, but it's checking what's in stock and what's on shelves and asking, checking what's in the back rooms and
The
whatnot.
inventory.
And exactly, they do store mapping as well, which is a slightly different thing, but is based on slightly more cameras.
Got it.
Um, so that was my work on the Jetson team. We were building ARM was newer, so we were building PyTorch from scratch for ARM and whatnot.
Wow.
Um, Later on, I joined the Deepstream team. This was slightly different from my work on the Jetson team in the sense that Deepstream is an SDK for high performance parallel online video inference. And by online, I mean live, real time.
Got it.
So what the work I did there was understand Deepstream and build a similar solution in Intel OpenVINO, which was the other up and coming video inference SDK. And then I wrote a white paper about, hey, how a 4 GPU node running um a NVIDIA GPUs and Deepstream cost about a fourth of what a dual, a multi $10,000 Intel node running two Xeon Gold CPUs. So it
Got
cost one fourth and gave you 4x the performance
it.
for video inference. So we wrote that and got done with that.
Wow. So it's being both hardware side of things, pretty close to a processor, and Deepstream is kind of an abstraction layer where you're processing a lot of real-time video, audio, etc. Am I correct?
Exactly. Yes.
Got it. Awesome. Awesome. So, how does your role at NVIDIA look like? I mean, you're a generative AI lead. So, how what kind of projects or what kind of endeavors are you kind of responsible for? How does it look day to day for you?
Sure. So I got pulled into building the generative AI pipeline at NVIDIA sometime late last year, when I was asked to refresh a number of GAN-based models and a number of GAN-based demos on our AI playground. In doing so, I also got asked to build something called Monocle, which became a demo for generative AI internally to add generative AI to the company DNA, and externally, in the sense that we presented it to Congress a couple of times in order to teach them about generative AI, um, so that they can make good policy decisions in the future.
Got
Uh, Based on that work, I got pulled into building Picasso. And so my days are wrapped around that, meeting with customers, making sure our CI/CD teams are in sync with what we need to do for our research models, and making sure that we are going forward and being good stewards of generative AI in terms of training models responsibly with data that we have licenses for,
right.
and making sure that the new class of generative AI workflows that are coming about are going to be powered by NVIDIA technologies.
Got it. Got it. So pretty broad role there, right from responsible AI to managing all the offerings that you're coming out with, uh, about which we will speak about Picasso soon. So before that, wanted to understand NVIDIA's history in generative AI. Of course, NVIDIA has played a very key role in the generative side. If you could kind of help us, rewind to how has NVIDIA played a role in this generative space.
Sure. I think generative AI exploded when GANs came about. NVIDIA launched something called GAN at GTC many years ago, where they would allow people to draw with, like you would in MS Paint. You could draw a hill, you could draw some rivers, you could draw artifacts in the sky and whatnot.
Right.
And a model would turn that into a realistic photo of, for example, a canyon, with a river snaking its way through it, and a sunny day and whatnot. And it would not look something out of ordinary in a subreddit like r/landscapes. So we did a bunch of work with GANs through GauGAN. We extended that to GauGAN 360, which now, instead of generating a single two-dimensional image, generates a panoramic view that people
Wow.
can play around with. These are some of the demos I was asked to refresh. We did some work with in-painting with GANs. And then early 2 years ago, I believe, we started working on nerfs to capture a 3D representation of a scene based on pictures taken of it. Then OpenAI launched Clip and other contrastive pre-learning models, which led to the rise of models like Stable Diffusion and NVIDIA's own model called Edifi, which was in development along with Stable Diffusion. It's just that the Stable Diffusion team at Compass and Stability pipped
Right.
us to and released their paper earlier.
Right.
Now we are, based on the work that we've been doing, we are working on Picasso, which is a class of text to image, text to video, text to 3D, and edge to image, all kinds of things, models.
Awesome, awesome. So, I mean, I would love to learn more about Picasso. So, you're closely associated with Picasso. Picasso is an API service, as far as we've seen outside, for generative AI models. Can you help us understand more about Picasso and where is it heading?
Sure. Picasso is built on top of something called NVCF, which is NVIDIA Cloud Functions, which is our way of hosting generative AI models, or basically any workload. We should not link it to generative AI per se.
Right.
Basically, any compute workload in a multi-cloud sense on DGX Cloud, which is NVIDIA's name for all of its capacity, be that in Azure, OCI, GCP, AWS, or other clouds that we have on our own. So that is DGX Cloud, and NVCF uh, is our function for is what we use to do cloud inference and
Got it.
cloud computation. Picasso builds on top of that by using models from our research team, such as Edify, and the text to video and the text to 3D models,
Right.
and in the future, models from people like Adobe and whatnot.
Right.
So we bring on Adobe's model, and then Adobe can use their model through Picasso in their applications.
Got
So we let large top 500 enterprises who are dipping their toes into generative AI come to us, and we will give them our IP. They might come with their own data and train
it.
our models on their data, but
Mhm.
we will do the computation and send them a nice bill at the end of the month.
Got it. Got it. So basically, simplifying generative AI for large companies that are trying to get into the space in terms of
Exactly.
text, images. Awesome. Awesome. So, what's cooking inside NVIDIA with respect to generative AI? Anything exciting for the next 3, 6 months? Anything that we can expect as a release or announcement?
Definitely. I can't say too much material information, but the goals that my team and I have are to make sure that we are getting Picasso out of the door, making sure our text to image, our text to video, and text to 3D models are ready for all the customers we plan to bring on, making sure we are making very good use of the resources that we have access to within DGX Cloud, um, making sure that we are not splurging money on wasteful compute, um, being good stewards of generative AI by training the models that we have responsibly on
Right.
data sets that we know are ethically sourced,
Right.
and finally improving inference performance and improving training performance so as to lower the cost to the environment because as people might have noticed, the energy cost and
Right.
heat release from these workloads can be significant at a large scale.
Right, right. So quite a lot of development happening inside. And yeah, of course, I think responsible AI is something that we've been hearing consistently from NVIDIA. Basically, making sure that all the models are trained responsibly with data that you have access to. Sounds good.
Exactly.
Uh, I was curious about, from your perspective, from your vantage point, what are some of the new markets that are starting to see use cases using generative AI? Any areas that you see from your perspective is kind of adopting this first?
Right. So currently, we've been seeing a lot of creatives pick up generative AI, utilize them. On the other hand, we are seeing a couple of new markets pop up. So game studios are incorporating generative AI rapidly into their game engines,
Right,
just for their developers, reducing the time it takes to create new assets within games, text to 3D for 3D assets, and text to image for isometric assets or mobile game assets. We have robotics adding generative AI really fast in order to create simulation environments and to create lighting for these environments, lighting, shadows, interactions between elements in the environments.
right,
Finally, we have models like Bing GPT, where image generation is becoming a core part of search.
right.
And so we have search bring on generative AI art or generative AI in a big way.
Got it. Got it. I was curious about robotic use cases. So you mentioned that uh, generative models are now being used to create data for training in some sense. So do you see synthetic data kind of being, changed or impacted with this generative types of technologies coming in?
I definitely believe synthetic data generation is going to be impacted in a big way with generative AI technologies coming in.
Right.
For example, Omniverse, uh, NVIDIA's like toolkit or like engine for visual sciences is enabling generative AI by allowing people to bring in or create assets within it
Right.
with APIs like, hey, I want to use DALL-E, or I want to go ahead and use something like ChatGPT to create a prompt or to describe a scene that I will then place a agent like a robot in to learn its environment.
Right, right. Yeah, it becomes quite easy to kind of create different scenarios and environments with the whole 3D aspect of generative, at least. Got it. So I had this question about LLM versus diffusion. Uh, how much important would each one of these verticals be to NVIDIA from your perspective? Do you see a lot of activities? Of course, we see a lot of talk and noise and chatter about the GPT or the text use cases a lot, primarily because consumers are directly kind of facing the app. They're able to log in themselves and start using it, and then you have these diffusion models or image creation editing models, which then lead on to help you create videos and 3D assets as well. uh, what I mean, I know both of them have their own importances, but how do you see both of these models play out in terms of NVIDIA? Are you going to be focusing more on one type of models, or how does that work?
Well, NVIDIA being, I believe we have enough people to focus on both, but I think, and this is a little sad for me, but I think LLMs are a bigger focus at NVIDIA, just because of because of ChatGPT. Everyone is using LLMs.
Right.
Diffusion models, on the other hand, is something that creatives are looking at. It's not you go out and you don't see regular people using generative AI models outside of something like Snapchat, where they've seen an anime filter.
Right.
So just in terms of hey, people know of these models. LLMs are seeing a lot more recognition,
Right.
but at the same time, as a company, we have to make sure that we explore the TAM that exists within generative AI art as well, because
Right.
the creative publishing and the creative space is a very would provide the company with a very massive moat.
Right, and of course, NVIDIA being NVIDIA is closely tied to like creators. I remember kind of using GPUs with After Effects, Premiere Pro, and so many other softwares to make them like 5-10x faster.
Exactly. Yeah. For example, we work closely with Topaz to improve their upscalers. We work very closely with companies like Pinterest, Snapchat, and the like to empower them to do the work that they're doing
Got
in
it.
training or inference with the next class of models.
Got it. Got it. Awesome. Awesome. So I'll probably move towards the actual discussion point today, which is regarding optimizations. So inference optimizations on GPU, how important is it before we deploy these models at scale, especially these LLM and diffusion models? Would love to understand from your perspective the importance of optimizing before you deploy.
Sure. Optimization basically comes down to a few things, right? You want to shrink your data formats from FP32 to something like FP16, Int8, FP6, FP8, or something else, or like something like BF16 or TF something.
Right.
So you want to shrink your data formats to reduce the bandwidth cost of moving data around and the how memory intensive your models get. So you want to do that. You also don't want to lose any accuracy.
Right.
Um, so that's one of the optimizations people go for. There's kernel auto tuning, which is for every single operation in your model, choosing the best compute kernel that makes the best use of the resources within the GPU. There is fusion, which is where you fuse operations that would have been multiple steps in
Right.
the GPU pipeline or multiple cycles and
Right.
fuse that into a single cycle operation. Um, Distillation and pruning to make the models lighter without any performance, without any accuracy cost,
Leverage.
and then reducing the number of memory copies you need to do.
Right.
For LLMs, data formats and kernel auto tuning play a significant role.
Right.
And NVIDIA has a SDK called Faster Transformer to do that for LLMs. We see up to 10x improvement over native PyTorch
Wow.
on models like T5 or GPT-J, which are smaller models,
Right.
the performance lift is reduced for larger models because you have more memory. You're constrained more by memory bandwidth than you are by data formats or kernel auto tuning. There might get something like a 4x performance uplift for GPT class models,
Wow.
which is still significant. Um, Faster transformer also drops the amount of memory you need, so you can
Right.
have multiple models live at the same time.
Got it.
Uh, for diffusion models, you really want to do stuff like the fusion of operations is really what gives you the most oomph when it comes to diffusion models. There is a fused multiply add in a block within the diffusion models that if you can optimize, will give you a significant uplift in the unit. And so that is the main optimization most frameworks like AI template, TensorRT, and Xformers try to do.
Right.
And then you have other optimizations like memory efficient attention, which is something that's native to all three. It's just that TensorRT also does kernel auto tuning and therefore gets the best performance.
Got it. Got it. So, I mean, there are a bunch of tricks or bunch of techniques, as you can put it, and that still needs to be explored over the next couple of months to years. Do you see that there's a lot of scope for optimization, kind of to help us, fast track deployments? Because if you go from like 1x speed to 10x speed, 10x lower memory consumption, this is going to allow us to do more inferences without adding a lot of cost, and of course run more models per GPU, decreasing the amount of GPUs required, and of course the carbon footprint that comes with it. That's pretty much the. Do you share the same views? Is what I'm trying to ask. Like,
So what I'm hearing is you're trying to ask if there are more optimizations coming for, let's say, diffusion models. I believe there are, just in the number of papers that I'm looking to, and a lot of them are architectural improvements to the model itself instead of eking more out of the same GPU.
right,
So you have stuff like parameter fusion, where instead of using the 64 by 64 input as the initial sample for stable diffusion, you still do 64 by 64, but you compress similar weights together,
right,
which can improve performance slightly. You can have other model improvements such as distillation, the way stability presented it, where you can go down from needing 30 steps to needing 5 steps
right,
of a denoising.
right,
There are other things. There's other work ongoing to make our samplers even better.
right,
If people remember, initially you needed something like 50 steps with a DDIM sampler.
right,
Now you're down to something like 30 steps with a Euler ancestral sampler, and then you can people are making do with even 20-ish steps with intelligent samplers.
right.
So better samplers and making our current samplers faster is also a goal to make sure that we shrink the carbon footprint of this technology we're trying to leverage.
Right, right. Awesome, awesome. So, last but not least, would love to understand. There are a lot of tools available for inference acceleration in the market. Onyx, TensorRT, of course, our VoltaML also helping in inference acceleration. Would love to know which tools should people or developers use. How do you choose these tools, and if you kind of throw some light on what are the advantages or disadvantages of any tools that people are using today?
Definitely. Um, So in general, moving slightly away from the generative AI world, we have found that turning your models into Onyx models and then running through a Onyx graph surgeon path, which does the fusion for you,
Right,
gives you a significant amount of speed up on GPUs.
right,
Because Onyx Graph Surgeon, what it'll do is it'll go ahead and look at your Onyx graph. For reference, Onyx is a framework independent representation of neural networks where it takes every single operation, mathematical operation, be that it be a PyTorch operation or a TensorFlow operation, into a common operation, which they describe in their opsets. So once you have an ONNX representation of a model, you can then run a ONNX graph surgeon pass, which, given your model graph, will go and find subtrees within that graph and see if they can be optimized into GPU kernels that it knows will be fast, and then reassembling your model through that. It's fairly fast to do that.
Got
And
it.
then once that is done, you can use ONNX runtime from Microsoft and NVIDIA to then use the CUDA execution context to leverage the GPU, or the TensorRT execution context to leverage TensorRT, where TensorRT will then, given the ONNX simplified graph, go in and see if there are subtrees that can be replaced, ONNX subtrees, which can be replaced with TensorRT subtrees.
Right.
And then the rest of the inference would happen in ONNX. So this would be something like in-framework TensorRT performance.
Right.
Uh, there's obviously full TensorRT, which requires some more work. For diffusion models, we have something called demo diffusion, and with 8.6, it's built in
Right.
to TensorRT, where you can optimize your stable diffusion model with TensorRT 8.6, get the engines, and then use the TensorRT runtime to do inference.
Right.
And then Volta ML has made optimizing these models a lot easier by introducing a binary that people can now use to optimize their engines instead of having to go through the entire TensorRT installation workflow.
Right. Right. Awesome. 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 So, I mean, I'm pretty much done with the questions here. Probably we'll open it up to the audience if they have any questions. And I had one question to just start with, which is, how do you see the balance between requirements for training and inferencing as far as compute's concerned? So, do you see like 50, 60, 70% of compute being used for one type of task today, or is it like training uses the same amount of compute that inferencing is using? And how do you see this changing over the next 1 to 2 years?
Right. Currently, I think inference takes a lot more compute, or just in terms of carbon footprint.
Right.
So the carbon footprint of inference is a lot more than the carbon footprint for training, because we don't have a lot of companies training stable diffusion from scratch currently. We have them taking checkpoints that have been green boothed or something different, and then fine tuning them or using LoRa. We In the future, I do think that training is going to take a lot more work, and a lot more the carbon footprint for training will increase, because people, in order to become better than your competition, you need to have better models
Right.
and you need to have discrete capabilities. So vanilla stable diffusion's dataset, which was layer on 5B, was relatively crap. So you really want to move away from that, just for quality reasons, and even for copyright risk, because layer on 5B had images that were
Yeah.
scraped without consent,
Right.
or without significant or so the creators had not said that they wanted to be included. The assumption was that if these images exist on the internet, they are fair use,
Right.
um, which is not a completely defensible argument.
Right.
So for copyright rights, people are training a lot more models from scratch,
Right.
and going forward, I expect the carbon footprint to increase. To that end, NVIDIA is doing significant amount of work
Right.
to improve to reduce training times with multi-GPU optimizations, torch inductor, and whatnot.
Right.
The best open source training for stable diffusion is currently from Colossal AI, and NVIDIA's training performance is significantly better than that. Is all I can say, and we just need to be on the lookout for that.
Got it. Got it. So pretty much a lot of compute is today being used on the inference side, but as you're saying, a lot of people are training their own models or fine tuning their own models to make sure that they're not getting into the whole copyright issues, and then we will see like more compute being used for training, with the nature of like training itself being happening more commonly.
Exactly. Yes.
Got it. Got it. Awesome. Awesome. So cool, Dhruv. I think that's it from my side, and thank you so much for coming today. Great kind of chat. I'll open it up to questions and read it out of the chat, and maybe we can spend 5 to 10 minutes answering audience's questions.
Sounds great.
Awesome.
Would you like me to read the question?
I can read it for you.
Okay, perfect.
So we have one from Harish, and hi Dhruv. Is NVIDIA releasing any open source foundation models to compete with OpenAI or other big tech companies?
Um, we are not releasing models per se. We are, however, still publishing all the papers. So NVIDIA is not currently releasing weights, but it is publishing papers that will allow people to recreate some number of our foundation models.
Right.
So going forward, you'll have Nemo LLM. Nemo will be empowering the next class of large language models and will come with the architecture for all the foundation models that NVIDIA creates.
Right.
Uh, for generative AI art, we are currently not releasing Edifi or the text to video or text to 3D models. However, we have published papers for text to image and text to 3D for people to read and understand how they work, because I believe that we are just broaching the models currently. There is a lot more work to be done,
Right.
and I think there are a lot of other companies that can do significant work with what NVIDIA is currently putting out in terms of architecture. Because, well, this is just the start. The architecture will improve over time, because nobody knows what is the best architecture for a diffusion based model. Is it multiple units? Is it a single unit? Is it something like composable control net? Is it control net or composable diffusion, where you have one unit that's frozen and the other one that can change with training or fine tuning?
Right.
So we publish papers, but we are not currently publishing weights, just because weights will have data IP for on the companies that we are partnering with to train these large language or large image models. Let's just say our partners would be very mad if we release the weights.
Got it. Got it. Is Nemo open source or just the architecture?
Nemo is an SDK, which is fully open source, and it describes Nemo stands for neural modules, and it defines building blocks for companies to build conversational AI and vision or uh, generative AI pipelines,
Got it.
and train those pipelines.
Got it. Got it. So it's more of an SDK.
Yes.
Got it. We have one question from Shagun Nagar. Where do you see bigger market for generative AI, text to image, conversational AI, etc.? Consider both OpenAI and Bard are in B2B or B2C space.
I think there is a so in terms of markets, I think text to text, which is conversational AI, is a significantly larger market than generative AI art. However, there are a number of very large players in text to text already.
Right.
So you'd be going up against the likes of OpenAI, Writer, companies whose entire business model it is to optimize the UI and the UX as well for these workflows. ChatGPT showed people how much more could be done with a GPT class model if you attached a new nice UI to it,
Right.
and they've been improving their UX over time. So competing with that is slightly hard, just in terms of the work I've seen within the company. We have the models we have are significantly larger and significantly better
Got
than OpenAI. It's just that, hey, the UI takes a lot of work, and we want to compete, and we will compete. It's just that, hey, we are going into a very crowded market.
Right.
Text to image, on the other hand, is a nascent market in comparison to text,
Right.
and I think there's a lot more revenue and work to be done there that NVIDIA can be spearing.
Got it. Got it. Got it. Awesome. I think that's all with the questions. Awesome. So Shagun's typing something. Just give it a minute. Thank you. He said thank you.
That is not a question.
Yeah, awesome. So thanks a lot, Dhruv. Great chatting with you. Hopefully, we'll catch up in a couple of months and see where things are with respect to generative AI. And if you have anything else to share, feel free. And anyone in the audience, Dhruv is on LinkedIn. You can kind of search him up, follow him. A lot of latest news, especially from generative AI side of things. You can follow him for that. Thanks, Dhruv.
Thanks. All right.
Thank you. Bye bye.
Bye bye.